everyone, I'm Juanita. Welcome to Scientific Python Interviews. Today we have Ross Barnowski. He's a scientific software developer at the Berkeley Institute for Data Science BITS, supporting open source scientific Python projects. He is active in both the NumPy and NetworkX projects and interested in the entire scientific Python ecosystem. He holds a PhD in nuclear engineering from UC Berkeley and previously served as an assistant research scientist and lecturer in the Department of Nuclear Engineering. Hello, Ross. Can you please introduce yourself?
Hi, Juanita. Thank you. That just about covered it. So I'm Ross. I've been at the Berkeley Institute for Data Science for just about 3 years now, working on open source scientific Python, which I love and I'm really excited to talk about.
Thank you so much for being here. So what drove you to contribute to open source, and what was your first open source contribution?
Let's see, what drove me to open source scientific Python was definitely my grad school research. So I worked on radiation detection, instrumentation, and imaging in grad school, which involved a lot of working with array data. So basically data from radiation imaging and spectroscopic instruments. And so for that, we started working with NumPy. We needed a tool that would that we could work quickly and efficiently with, and also where the code was very clear, because obviously working with other grad students, you need to be able to communicate with them and not have, giant files that no one can read. And NumPy and Matplotlib and all of the scientific Python tools were definitely where we turned for that, and allowed us to work very, very quickly, which was super nice. I would not have gotten out of grad school without scientific Python.
Same for me.
Yeah, exactly. I think it's true for a lot of people. And then regarding the first contribution to open source, to open source generally, I would guess that there's probably something way back in my deep, dark grad school past. We used a lot of tools from something called the Robot Operating System, which is coincidentally also called ROS. I would guess that my first open source contribution was probably to one of those tools, but then for scientific Python specifically, I don't know exactly, but I can almost guarantee you it is a documentation fix, probably in NumPy.
Wow. And now you are one of NumPy's maintainers, right?
Yes.
So what does it mean for you to be a NumPy maintainer?
That's a good question. And I think that it's something that there's a lot of misconceptions about. So I think a lot of people, when you say, you're a project maintainer or core developer or something like that, they envision a team of 50 engineers that work for Google and Facebook and have, decades and decades of programming experience. But in my experience, that's definitely not the case. And to me, being a maintainer, I think maybe a better word for it is just active participant. Because there's so many different facets to the project. There is, of course, code development, but a lot of it, there's community decision-making is basically the model that everything is built on top of. So community is very important. And I think that is probably the most important aspect of working on an open source project, is just being present and participating in meetings, in all of the open meetings that we have for NumPy, for NetworkX. And yeah, just interacting with as many people as possible, trying to help answer questions, trying to fix bugs, it's just the whole gamut.
Yeah, I get that. I've also read that you work on the survey too as a maintainer. Mm-hmm. So I would like to know, how do you think the survey impacts the NumPy roadmap?
Yeah, so that's a great point. Dovetailing on the previous point I was making, so the survey is sort of like a sub project. It was an idea of one of our contributors, Inessa Pawson. It was an awesome idea because one of the challenges that open source projects have is really interacting with users and getting user feedback. Of course, we have the GitHub issue tracker, which people raise issues on when something doesn't make sense, or there's they can't figure out why their code doesn't work. But if you look at NumPy we have no idea how many users there actually are, but it's definitely in the millions. And we don't get interaction or feedback from millions of people. So the coverage that we have in terms of what our users want, need, and all of that type of feedback, we have very little feedback mechanisms for things like that. And that's why the survey was a great idea. We've done it 2 years in a row, and there's been some really valuable feedback there in terms of people telling us what features they use the most, which is a great way for us to sort of know what to focus limited attention on, and also what components that they really care about. So that's incredibly valuable feedback to have.
Yeah, I think so too. I mean, survey makes like a lot of sense to get closer to users.
Exactly.
And I mean, that's what open source is for, so.
Right.
So I mentioned before that you work in NumPy and in NetworkX. So I wonder, how do you handle working in more than one project, and what is the greatest challenge of it?
Yeah, that's, I think maybe not so much a challenge, but definitely the thing to be the most mindful of is that the projects, like each project really has a different character, because the communities of the people that work on the projects are different. And also, the goals and user bases of the projects are also very different. So for example, because NumPy has been around for so long and is used by in so many places, not just NumPy itself, but also NumPy's API. There are a lot of libraries that interact with NumPy's API, like Dask and CuPy and things like this. So API stability and just general project stability is extremely important for NumPy, which means that if you want to adding new functionality is hard, because it has to go through a very rigorous review process in order to demonstrate value and convince all the stakeholders that something should be added to it. Whereas a project like NetworkX is not depended on by as many core libraries and sort of has a faster development pace than NumPy. And so just keeping differences like that in mind is really, that's the key. I can't come in and I don't go to NumPy and say, I want to add 5 new functions. Whereas, people propose things for NetworkX all the time, and they tend to go in much quicker because it's just a different feel and different community for the two projects.
Yeah, that makes sense. And I think that's important when people start choosing their projects that they want to contribute to, like knowing the difference between them. That's a great thing to know.
Yeah, definitely.
So this one is a hard one. What do you think you're doing to make the scientific Python community better?
Oh, that is a hard one, and I hope I have an answer for it. I would say focusing as much time as I can on reviewing. So I think that reviewing other people's contributions is probably in my experience anyways, it's one of the limiting factors in basically all open source projects, because you need people to review and understand, proposed changes and things like this. And in a lot of cases, that's extremely difficult. It requires a lot of context and a lot of extra knowledge. And it just takes a lot of time. And so that is the component that I think most open source projects struggle with the most. And so that I try to, as a maintainer or a core developer of these projects, I think that's what I try to spend as much time possible reviewing incoming contributions.
That sounds great, and also very hard. I imagine reviewing others people's codes might be challenging.
Yeah, it turns out that it's also incredibly rewarding, because that you learn so much from just reading other people's ideas and communicating with them. So, it's sort of surprising. It seems counterintuitive that you learn the most from reviewing rather than, writing your own code. But I think that's definitely true, at least in my case.
Yeah, and I think one of the greatest things about open source is this sharing knowledge between developers. So I think that's great that you're doing that.
Yeah.
Okay, last one. Can you give some advice to someone that wants to contribute to the scientific Python ecosystem?
Yeah, so I think this is one of the most common questions that I come across when interacting with new contributors is where do I start? Which is a huge loaded question, but I think that the best piece of advice that I could give is that you should definitely start by following your interests. So there are so many different tools and so many different applications for everything. A lot of people come to the libraries through applications. For example, I came through radiation instrumentation. One of the things that we do is work on like spectroscopic analysis of radiation data. And for that, we use histograms constantly. And I think that was my entry point into NumPy and Matplotlib specifically, was through thinking about histograms and reading the code and the documentation there. So yeah, definitely follow your interests. And the other general advice I would give is just read code. So, that's everybody is always really excited to start, and everybody wants to contribute to add PRs and things like this, which is incredibly valuable. And I don't want to discourage anyone from doing that. But I think there's also a sort of a hidden trick in learning about something is that you gain so much from just reading not only code, but reading discussions for open PRs and sort of getting a sense for how people interact on projects. And just taking the time to do that can really just save you a bunch of time in the future when you do get to the point where, I want to make a change, I want to contribute my own idea. Having that background is incredibly helpful.
Yeah, I think that's a great advice. Okay, I think that was all for today. Thank you so much for sharing your experience with us. I think it's very valuable. And welcome to the Scientific Python community.
Thank you so much for having me. This was great.
Yeah.
Bye.